Hi guys, welcome to my study compass. In this video, I'll be walking you through the past paper, Math P2, Variant 3, May-June 2018. Let's get started. One day in Chamonix, the temperature at noon was 6 degrees Celsius. At midnight, the temperature was 11 degrees Celsius lower. Write down the temperature at midnight. To get the temperature at midnight, we simply subtract 11 degrees Celsius from 6 degrees Celsius, which is equal to -5 degrees Celsius. Factorize w plus w cubed. The terms have a common factor of w. When we factor out w, we are left with 1 plus w squared. Liz takes 65 seconds to run 400 meters. Calculate her average speed. Here is the formula for calculating the average speed. The distance D Liz runs is 400 meters and the time T is 65 seconds. When we type this into the calculator, we get 6.15 meters per second, rounded to 3 significant figures. Complete the list of factors of 36. We can get the factors of 36 by first listing out the numbers that multiply to give us 36. From this, we see that in addition to 1, 2, and 36, the factors of 36 also include 3, 4, 6, 9, 12, and 18. Increase $22 by 15%. To increase $22 by 15%, we simply add 15% of $22 to $22, which is equal to $25.30. Write 209,802, correct to the nearest thousand. The number in the thousands position is 9. The number after 9, which is 8, is greater than 5. So we add 1 to 9, giving us 10. So we replace 9 with 0 and add 1 to the number before 9, which is 0. 0 plus 1 is 1. The numbers after 9 become 0. So we have 210,000 rounded to the nearest thousand. Write 4,123, correct to 3 significant figures. The third significant figure is 2. The number after 2, which is 3, is less than 5. So we maintain 2 and the number after 2 becomes 0. So we have 4,120 rounded to 3 significant figures. The probability that Kim wins a game is 0.72. In 1 year, Kim will play 225 games. Work out an estimate of the number of games Kim will win. To get this number, we simply multiply the probability that she wins a game, which is 0.72, by 225, which is equal to 162. Write 4.82 times 10 raised to the power -3 as an ordinary number. When we type this into the calculator, the number is converted to its ordinary form, which is 0.00482. Write 52 million in standard form. To write this number in standard form, we move the decimal point at the end of the number to a position after the first non-zero digit, which is 5. So we have 5.2. Since we moved the decimal point 7 units to the left, we multiply 5.2 by 10 raised to the power 7. Solve 1 minus p over 3 equals 4. When we multiply both sides by 3, this is what we get. When we make p the subject, this is what we have. 1 minus 12 is -11. Factorize completely. 2a plus 4b minus ax minus 2bx. The first two terms have a common factor of 2. When we factor 2 out, we are left with a plus 2b. The final two terms have a common factor of -x. When we factor out -x, we are left with a plus 2b. This can be rewritten as a plus 2b times 2 minus x. A equals 2 pi plus y times x squared. Rearrange the formula to make x the subject. When we divide both sides by 2 pi plus y, this is what we get. And when we take square root of both sides, we have x equals plus and minus square root of a over 2 pi plus y. Work out the number of elements in P intersection Q. You may use the Venn diagram to help you. Let's represent the number of elements in P intersection Q with X. We've been told that there are a total number of 10 elements in set P, which means the number of elements in set P only would be 10 minus X. We've also been told that there are a total number of 13 elements in set Q, which means the number of elements in set Q only would be 13 minus X. We've also been given that the number of elements outside P union Q is 5. If this is the case, then the number of elements in P union Q would be equal to the total number of elements in the universal set, which is 20, minus 5, which gives us 15. So now 10 minus x plus 13 minus x equals 15. 10 plus 13 is 23. Minus x plus x minus x simplifies to minus x. When we make x the subject, this is what we have. 23 minus 15 is 8. Simplify. 3 plus x over 9 minus x squared. The denominator, 9 minus x squared, can be written as a difference of 2 squares, which is 3 squared minus x squared. By applying the factorization for the difference of 2 squares, we can rewrite it as 3 plus x times 3 minus x. 3 plus x cancels out, so we have 1 over 3 minus x. O is the origin, OP is P, and OQ is Q. QT is to TP equals 2 is to 1. Find the position vector of T. Give your answer in terms of P and Q in its simplest form. OT can be expressed as OP plus PT. PT is 1/3 of PQ. PQ is PO plus OQ. OP is P, PO is negative P, and OQ is Q. When we expand the brackets, 1 over 3 times negative P is negative 1 over 3P. 1 over 3 times Q is 1 over 3Q. P minus 1 over 3P is 2 over 3P. So we have 2 over 3P plus 1 over 3Q. Without using a calculator, work out 2 over 3 divided by 1 over 5. You must show all your working and give your answer as a fraction in its simplest form. First, we need to convert the mixed fraction 1 over 5 into an improper fraction. So 5 times 1 plus 1 is 6, which we divide by 5. In the next step, we bring in 2 over 3. Then we replace the division with multiplication, and then bring in the reciprocal of 6 over 5, which is 5 over 6. 2 goes into itself 1 time and goes into 6 3 times. So for the numerator, 1 times 5 is 5, and for the denominator, 3 times 3 is 9. 5 over 9 cannot be simplified further, and so that will be our final answer. The length of the side of a square is 12 centimeters, correct to the nearest centimeter. Calculate the upper bound for the perimeter of the square. To correct the length to the nearest centimeter, we have 12 centimeters. Then we bring in plus and minus 1 centimeter. Then we divide 1 centimeter by 2. Here is the formula for the perimeter of a square. So to get the upper bound of the perimeter of the square, we multiply 4 by the upper bound of its length, which is 12 plus 1 over 2 centimeters. This gives us 50 centimeters. Jo measures the length of a rope and records her measurements correct to the nearest 10 centimeters. The upper bound for her measurement is 12.35 meters. Write down the measurement she records. The upper bound of her measurement would be equal to the measurement she records, which we are calling x, plus 0.1 meters divided by 2. We've been given the upper bound of the measurement to be 12.35 meters. 0.1 meters divided by 2 is 0.05 meters. When we subtract 0.05 from both sides, we get x equals 12.3 meters. Find the value of 1 over 81 raised to the power negative 3 over 4. When we type this into the calculator, we get 27. Simplify. Cube root of 27t raised to the power 27. By applying this rule in the laws of indices, we can rewrite this as 27t raised to the power 27, or raised to the power 1 over 3. And by applying this rule, we can rewrite this as 27 raised to the power 1 over 3 times t raised to the power 27, or raised to the power 1 over 3. 27 raised to the power 1 over 3 is 3. According to this rule, the powers of t multiply, so 27 times 1 over 3 gives us 9. So we have 3t raised to the power 9. Expand the brackets and simplify. 2p plus 3 times 3p minus 2. When we expand the brackets, each of the terms in one bracket multiplies all the terms in the other bracket. So 2p times 3p is 6p squared. 2p times negative 2 is negative 4p. 3 times 3p is 9p. 3 times negative 2 is negative 6. Negative 4p plus 9p is 5p, so we have 6p squared plus 5p minus 6. Y is directly proportional to x minus 1 squared. When x is 3, y is 24. Find y when x is 6. In mathematical terms, we write y is directly proportional to x minus 1 squared. This can be rewritten as y is equal to a constant, which we are going to call k, times x minus 1 squared. We need to find k. To get k, we plug in the values of x and y given in the question. So we have 24 equals k times 3 minus 1 squared. 3 minus 1 squared is 4. When we divide both sides by 4, we get k equals 6. Now that we know the value of k, when x is 6, y equals 6 times 6 minus 1 squared, which is equal to 150. The points A, B, C, D, and E lie on the circumference of the circle. Angle DCE is 47 degrees and angle CEA is 85 degrees. Find the values of W, X, and Y. Chord AC subtends 85 degrees at one point on the circumference and subtends x degrees at another point on the circumference. These two angles must be equal, so x equals 85 degrees. The sum of the angles in this triangle must add up to 180 degrees. So to get y, we subtract the sum of 85 degrees and 47 degrees from 180 degrees, which is equal to 48 degrees. ABCD is a cyclic quadrilateral. Opposite angles in a cyclic quadrilateral must add up to 180 degrees. So to get W, we subtract 85 degrees from 180 degrees, which gives us 95 degrees. Write as a single fraction in its simplest form. 1 over y minus 1 minus 1 over y. To get the LCM, we multiply the denominators, which gives us y times y minus 1. For 1 over y minus 1, y minus 1 goes into the LCM and we are left with y, which multiplies the numerator, which is 1. So y times 1 is y. For 1 over y, y goes into the LCM and we are left with y minus 1, which multiplies the numerator, which is 1. So y minus 1 times 1 is y minus 1. When we expand the brackets, negative 1 times y is negative y, and negative 1 times negative 1 is 1. Y minus y is 0, so we have 1 over y times y minus 1. Find an expression for the nth term of each sequence. When we look at the terms in this sequence, we see that they have a common difference of negative 4. So we can use this formula to get the nth term for the sequence. A1 is the first term, which is 11. D is the common difference, which is negative 4. When we expand the brackets, negative 4 times n is negative 4n. Negative 4 times negative 1 is 4. 11 plus 4 is 15, so we have 15 minus 4n. For this sequence, the terms have a common ratio of 2, so we can use this formula to get the nth term. A1 is the first term, which is 3. R is the common ratio, which is 2, so we have 3 times 2 raised to the power n minus 1. Calculate the value of x. To get x, we apply the cosine rule to the triangle. This gives us 13 squared equals 11 squared plus 5 squared minus 2 times 11 times 5 times cos x. 13 squared is 169. 11 squared plus 5 squared is 146. 2 times 11 times 5 is 110. When we subtract 146 from both sides, this is what we get. And when we make x the subject, this is what we have. When we type this into the calculator, we get 102.1 degrees rounded to 1 decimal place. The diagram shows the speed time graph for 60 seconds of a car journey. Change 90 kilometers per hour to meters per second. To change kilometers to meters, we multiply 90 by 1000. 1 hour is 3600 seconds. When we type this into the calculator, we get 25 meters per second. Find the deceleration of the car in meters per second squared. The car's speed decreases between these 2 points. The slope of this line gives us the deceleration of the car. So that will be 90 minus 0 kilometers per hour divided by 40 minus 60 seconds. 90 minus 0 kilometers per hour is 90 kilometers per hour. The final answer needs to be in meters per second squared. So we need to convert 90 kilometers per hour to meters per second. We did this in the previous question and we got 25 meters per second. When we type this into the calculator, we get negative 1.25 meters per second squared. Since we are asked to give the deceleration, we ignore the negative, so the deceleration is 1.25 meters per second squared. If we were asked for the acceleration, then we include the negative. Find the distance traveled in meters in the 60 seconds. The distance traveled is the area under the speed time graph, which is in the shape of a trapezium. Here is the formula for the area of a trapezium. From the graph, we get A to be 40 seconds, B to be 60 seconds, and H to be 90 kilometers per hour. The final answer needs to be in meters, so we convert 90 kilometers per hour to meters per second, which is 25 meters per second. When we type this into the calculator, we get 1250 meters. In the diagram, PQ is parallel to BC. APB and AQC are straight lines. PQ is 8 centimeters, BC is 10 centimeters, and AB is 9 centimeters. Calculate PB. To get PB, we subtract AP from AB. We already know AB is 9 centimeters, so we need to find AP. Triangles APQ and ABC share a common angle. These two angles in both triangles are equal because they are corresponding. These two angles are also equal because they are corresponding. So based on the AAA criteria, the two triangles are similar. So to get AP, we can apply the concept of similar shapes, which says that if the triangles are similar, then their corresponding sides must be equal. So we have AP over 9 centimeters equals 8 centimeters over 10 centimeters. When we make AP the subject, this is what we get, which is equal to 7.2 centimeters. So now PB is 9 minus 7.2 centimeters, which is equal to 1.8 centimeters. The diagram shows two glasses which are mathematically similar. The larger glass has a capacity of 0.5 liters and the smaller glass has a capacity of 0.25 liters. The height of the larger glass is 13 centimeters. Calculate the height of the smaller glass. For the similar glasses, the ratio of their volumes must be equal to the cube of the ratio of their corresponding sides. So we have HS, which is the height of the smaller glass, divided by 13 cubed equals 0.25 liters divided by 0.5 liters. When we take cube root of both sides, this is what we get. And when we make HS the subject, this is what we have. When we type this into the calculator, we get 10.3 centimeters rounded to 3 significant figures. Describe fully the single transformation that maps triangle T onto triangle U. When we look at both triangles T and U, we can tell straight away that this is an enlargement by a scale factor of 2 because each of the sides of the image, which is triangle U, is twice its corresponding sides in triangle T. This is a positive scale factor because both triangles have the same orientation. From here, all we need to do now is to find the center of enlargement. We can get this by connecting at least two corresponding points on both triangles with a line. The intersection point of the lines is the center of enlargement. In this case, we get the center to be 7, 0. And so the full description for this transformation will be enlargement by a scale factor of 2 about the center 7, 0. On the grid, draw the image of triangle T after a rotation through 90 degrees clockwise about the point 7, 3. First, we need to mark the center of rotation, which is the point 7, 3. Then we rotate each vertex on triangle T 90 degrees in the clockwise direction about the center. This means if, let's say, we pick point A, we draw a line from point A to the center of rotation. Then we measure and mark 90 degrees in the clockwise direction from this line. From here, we draw a line from the center of rotation passing through the 90-degree mark. The final step is to now mark the new position of point A on this line such that the distance from the new position to the center of rotation is the same as the distance from the center of rotation to the original position of point A. After repeating the same process for all the vertices on triangle T, we are now able to map out the rotated image of triangle T. Thank you for watching. I hope you found this video useful. See you in the next video. Bye guys.